Hello guys, welcome to my YouTube channel. My name is Vishal Barot and today we are going to learn about business logic error vulnerabilities. What are business logic errors? So these are the vulnerabilities that arise due to flaw in design and implementation of an application, and this usually cause unintended behavior. And it is very less likely to identify this vulnerability using tools. I'm like, you cannot directly automate something that detects business logic error vulnerability because it requires user to understand how the application logic is working. So it is very less likely that you can automate something that will find you business logic error vulnerabilities. Uh, Understanding the application feature uh, is very required. I mean, like the functioning of feature and application is very much required in order to find this kind of vulnerabilities. Uh, Common business logic error vulnerability types. So first one is race condition vulnerability. Second one is price tampering. Third one is paid feature restriction bypass, and there are some other vulnerabilities as well. We cannot categorize them, but they are usually due to the flaw in UI and APIs. So let's talk about race condition vulnerabilities. So you can find these vulnerabilities using turbo intruder. For example, there is a cart, and you are supposed to apply a coupon over there. But if due to this vulnerability, if you are able to apply multiple coupons on the same item, I mean like same kind of coupon but multiple times on the same item, then it will be an example of race condition where you can abuse that functionality in order to apply too many coupon codes on the same item. I'm like of same coupon code of the same kind on the same item, right? For example, if there is an item of 1,000 rupees and I have a coupon code that gives me discount of 10 rupees, if I'm able to from a intended behavior of the application, I'm only supposed to use that coupon once on that item. But if due to this vulnerability persists on that particular functionality and I'm able to apply 100 such coupons on that particular item, then the total discount will be 100 into 10, which will be 1,000, and the price of the item is 1,000, which means I have to pay nothing to purchase that item due to this vulnerability. We will discuss more about this vulnerability, like different test cases. I mean, it's not just on the coupons but also many other places as well. So second one is price tampering. It is pretty simple and most popular one in the business logic error vulnerabilities, where you can buy a costly item with 0 rupees, or a very minimal price. So this is due to price tampering vulnerabilities. uh, Third one is paid feature restriction bypass. For example, there are so many applications, they allow feature based access. For example, if I'm buying a premium feature, then I will have access to many functionalities of that application. I will give you some example of these applications like Truecaller, Tinder, Bumble. So there are so many applications. They have two categories of user: free users and premium users, where premium users are able to access premium feature of those applications. So there are vulnerabilities through which a free user can access premium functionalities. So this is the category of those kind of vulnerabilities. And there are UI API flaws. I mean, like there are no specific category of this kind of vulnerabilities, but yeah, there are sometimes flaw in the implementation of UI and APIs. They cause some business logic errors. Okay, let's explore some business logic error vulnerability with respect to different application functionalities. So I have created some POCs. I have some POCs that I reported on bug bounty programs. I have categorized those POC with respect to the functionalities. So in this session we are going to learn different business logic error vulnerability that we can find on different features of the application. So the first one is cart, second one is free user accounts, where we are going to use a free user account, and we are going to try to access premium functionality using a free user account by bypassing the restrictions using different techniques. Third one is order payment. This is I wanted to categorize card and order payment into in a same module, but I believe the attack types will be different. Which is why I categorized, I divided this into two different modules. On order payment, we will be talking about price tampering vulnerability, uh, and on cart we will be talking about adding items into the cart, applying coupons, etc. Okay. Third one is order payment. Fourth one is public private profiles and API UI elements. So there are many applications they allow you to set up privacy on your profile. Um, so through manipulating some variables in the API, or through manipulating the UI elements, you can do a lot of things. Apart from that, there are also certain UI elements or API elements in the application. They cause their separate business logic error vulnerabilities. Let's just start with the cart now. So on cart, we will talk about what are the different test cases that we can do on a cart. So to be specific, there are so many applications they allow you to buy a product, and when you add up, when you try to buy a product, it goes into the cart. So what are the different things that you can do in a cart? First thing is race condition on offer discount vouchers. So as I already talked about this in the first slide, that we can try to we can try to apply same coupon multiple times on the same item. I already gave you an example of that. Okay. Second one is guessable coupon logic and enumerating the coupon which are not even public. Oh yeah, so just wait a second. Let's talk about race condition a little more. I'm like just not while not talking about the cart, we can also find race condition on many other features as well. For example, if there is some restriction on the application where it allows only adding 5 emails, or it only allows a certain limits of data to be added, we can try to do race condition attack over there. We can use turbo intruder tool to perform race condition attacks. Uh, okay. Second one, guessable coupon code logic and enumerating coupon which are not even public yet. For example, if an application is using guessable pattern for the coupon codes, for example, flat 30, we can try flat 50, flat 100, flat 90, like this. Enumerating coupon code which are not even public yet. For example, tomorrow there is a after a week there is a big billion day sale, or any kind of sale that if I'm the website owner, I'm going to launch a sale after a week. I've already created the coupons, but I didn't make them public yet. So if someone is able to find those coupons before even they are public, then that is a vulnerability. How the attacker can find it? If he observes some pattern through the previous coupons. For example, if you are using timestamp in your coupon, if you are using like month date format in your coupon, then that can be a logic to find it. If you are using numerical identifiers in your coupon and in a sequential manner, that also can lead to find the future coupons, right? uh, and if the APIs are live, but just the coupons are not public yet, then you can use those coupons before even they are disclosed to the world. Third thing, applying coupon codes on unintended item. For example, if there are some coupon code which are only restricted on certain products, like some coupon code which is giving 10% discount on electronics item. If I'm able to use that coupon code on, let's say, T-shirt, then it is a vulnerability. uh, it will be business logic error vulnerability. Use restricted coupons or expired coupon. For example, if I'm working for Amazon and Amazon is giving special coupons to the employees, uh, they are checking if the person who is applying those coupon is having an Amazon.com or Amazon.in domain user account, uh, which I won't have because I don't work for Amazon. So if I use the normal Amazon account with at the gmail.com domain or any other domain except for the amazon.com domain, and if I'm finding some vulnerable API or vulnerable element in the UI through which I'm able to uh, use the employee coupon, even though I'm not an employee, and get additional discount, then that is a vulnerability. If I'm able to use expired coupon, sometimes this the expiry of coupon is only validated by the UI, It is not validated by the API. So if I'm able to using some vulnerable API, I'm used to able I'm able to use the expired coupon. Then I can just abuse that functionality and make get additional discounts, get discounts which I'm not supposed to get because the coupon is expired. So these are some test cases. Use one time coupon on multiple items. For example, there is a coupon which is giving me 100 rupees discount on Zomato on any item. So that is only a one time coupon. If I'm able to find a vulnerable API or UI element through which I'm able to use that coupon multiple times, then it is a vulnerability. Okay, so you have to find some vulnerability through which you can do this. These are just some ideas that might come across your head while exploring the card feature. uh, Third thing, cart purchase limit bypass. For example, there is an application, it allows minimum cart value of 100 rupees. If you buy something lesser than 100 rupees, it won't allow you to buy it. You can bypass this if the application is not properly validating the values through the APIs or through the cart, through the UI and the APIs. So you can bypass these limits by just finding flaws in the UIs and APIs, and you can try to bypass this limit and buy items below the minimum cart value limit. Right. This can also be some vulnerability. Uh, uh, there are also some subscriptions. Uh, they have certain limit. Like for example, I there is a subscription which starts from $6 per month. If I'm able to buy that subscription at $2 per month, right? Then also this will be a vulnerability because I'm bypassing the business logic. Modify monthly plans. This was an example that I already gave you. If there is a subscription $6 per month and I'm able to buy it for $2 per month by manipulating the parameters in the API or doing something else, then this is a vulnerability leading me to modifying monthly logic that has been assigned to that for those plans. Uh, Another one, buy out of stock items. For example, for my pin code, there is one item which is very less in quantity. Let's say two items are left for that particular two of such items are left for my particular pin code. I can just do one thing. I can if I don't want to if I want to buy the item, but not now, later on. At the same time, I don't want to risk losing that item. Then I can just simply add it to my cart and add it to my cart, leave it there, and place it after some time, after months or year. If the item still is processed, right, then it will be a vulnerability. Even if it is out of stock and it is processed, because I already kept it in my cart for months, then it is a vulnerability. Eliminating delivery charges for low cost item in the cart. For example, if I buy for low cost item, the delivery charges are applied. If I maintain a certain cart value, then the delivery charges are not applied. So what I can do is I can buy so many items same time, and then cancel all of the items, leaving the lowest cost item. For example, some item which is just for 10 rupees, right? I can leave it there and cancel all the rest of the items. Okay, there might be a chance that my item, the delivery fee on that particular item won't be applied for me, because at the moment the moment when I placed the order, I already had the minimum cart value for free delivery. So this can be a test case where you have to buy multiple items same time, and you have to cancel all the item except for the low cost item, and see if the delivery fee is still applied for that. Are you still getting the item for a for a free delivery? Uh, okay. Third one is, it doesn't come into the business logic error vulnerability, but still I mentioned it over here because we were talking about coupon codes. You can brute force coupon codes, see if the rate limit is there or not. If rate limit is not there, you can enumerate coupon codes. Some of the coupon code might not be supposed to be public, right? So you can do things like that. Okay, second scenario, free user accounts, non-premium user. For example, you are using an application as a free user, not a premium user, right? So there are certain things that you can do on the application. For example, there is an application that allows you to watch, to stream to some channels, right? But to stream such some channels, you there are some free channels, there are some premium channels, and you want to stream premium channels. So this is the API that gets triggered when you want to stream to the premium channels. This one, you can see API user 123. This is the numerical identifier of that user, slash premium slash stream and slash discovery channel. So let's assume that discovery channel is a premium channel, and only the premium user can stream discovery channel. If there is no proper restriction on this API on the basis of the users, on the basis of the non-premium user and the and the free non-premium user and the premium user, if the restriction is not there, then there is a chance that this API can also might also get triggered from non-premium user session. There is a chance. For example, also giving one more example, let's say there is some a premium feature that allows you to see the some special tokens, right? And the URL is user slash 123 slash premium slash special tokens. If you forcefully browse this URL in a non-premium user account, and if it shows you those special tokens, then this is also a vulnerability. So you can try to do force browsing of non-premium user endpoints, sorry, of premium user endpoints in a non-premium user session, and find vulnerabilities like that. You can bypass paid feature restrictions like that by accessing uh, premium user APIs or URLs in a non-premium user session. Tempering request response to enable premium feature. For example, if you're trying to access some premium feature, but in the response it is giving, in the request there is some parameter which is having some boolean value. For example, premium equal to true or premium equal to false. You can manipulate those values and see if you are able to access that premium feature or not. uh, it can be a response parameter as well. You can manipulate the response parameter, and it might be leading to a subsequent request where it will identify that user as a premium user, uh, but in reality it is a free user. And you can so the point is to observe the request response, see if you can manipulate something in the request response to get the premium features enabled. Play with the UI. Okay. uh, you can see if there is some premium feature which is disabled. You can play with the UI elements and just manipulate something in the UI element. For example, if there is some disabled element is added in some button, you can remove it and see if you can click that button, okay, to enable the premium feature. Check API flow. For example, there are there are applications, they restrict premium access only through the UI but not through the API, right? So always pass the traffic through burp suite and see if what are the APIs that are getting triggered, and see the data it is coming through these APIs. It might be possible that the data it is showing on the UI and the data that you are seeing through the APIs, it is completely different. There is some additional data coming which you are not supposed to see as a free user. So this can be a test case. Compare web versus mobile view. So for an application, it might be possible that it is allowing access to some premium feature using the mobile application, but not through the web application, and vice versa. So you have to check for that as well. Open additional features by signing up with @company.com, companyemail.com. On applications where verification functionality is faulty or missing. For example, if there's some application which is not confirming the email before giving dashboard access, you can just try to sign up with @company.com domain, because it might open some new APIs or features for you, because you are signing as an employee for that particular organization, for that particular application. So this is something that you can do. or if it is not giving you direct dashboard access, but still some verification is faulty, you can abuse that faulty verification for that particular email and get access to the application as a employee. It might be possible that the after signing up as an employee, you are getting access to some feature or able to see some sensitive data or other user data as well. For example, if I try to sign up on a portal with support at the rate companyname.com, I might be able to access some APIs which might show me data of some other users. Possible. Or I can just copy that token that has been created for me, and I can use that particular token or session cookie on some internal portal or on some restricted portal. It might be possible that the cookie I created here might be you. The main application might not be showing me some sensitive data or sensitive API, or no, might not be giving me some sensitive access, but it might give me sensitive access elsewhere on some other portal. So I can grab the cookie, load it somewhere else, and see if I'm able to get access to some functionalities or data which I'm not supposed to access. So this is one POC. Uh, this is just to demonstrate how I bypassed business logic error. I mean, like the premium feature restriction by just playing with the UI. Here you can see to create a custom service, I need to upgrade my plan. I have to upgrade my plan from free user to the premium user. When I right click on the learn more button and inspect the element, I can see the button, it is having a class element, and I can see the feature denied element is there, right? Yeah, like this. So I removed the value inside the client class element. Okay, and I can see that the button, when after clicking the button, I was able to add a custom service like this. Here you can see I was able to click the button and I was able to add the custom service. Initially, I was not, because I was not a premium user, but playing after playing through with the UI, I was able to enable that element, and I entered value in it, and I even saved it. And you can see here hacked. That is the custom service that I added. Right. So one thing to note: you always have to complete the entire flow. You just don't have to just play with the elements and see if it is getting enabled or not. You have to actually trigger that particular API as well, trigger that particular request as well, right? Because you can do anything on the inspect element, but it is not a vulnerability always, right? You have to see if it is leading, if making some request, and if the data remains persistent on the page. Here the data is persistent on the page. I added a service and it remained here. Even when I refresh the page, it remains here, right? Which means that it is a vulnerability. Second example, try to sign up with on applications where the some domains are restricted. I already gave you an example, right? You can try to sign up on a page where certain domains are restricted. For example, you're working for an organization and there is some portal where you specifically cannot register, right? Try to register there, right, by using capital letters like this. Okay, try to use capital letters like this instead of sorry, instead of using the small letters, you can use capital letters and try to bypass that restriction. For example, if I try to register on some internal portal or some support portal using at the rate amazon.com, or some customer portal using at the rate amazon.com, Amazon in small letters, and I try to register like that, it if it shows me an error like an employee cannot register on the support portal, then what I can do is I can just use the amazon.com in capital letters and try to register, see if the restriction is getting bypassed here. um, Also there are some, it's not just registration, it can be a paid feature, it can be anything, right? Where you have to enter only business domain, or on some only some restricted domains are allowed. In that scenario also you can use capital letters or combination of capital and small letters to bypass the restrictions. Here you can see the victim user rate at the gmail.com. It is not allowing it because it is a Gmail domain. So what I can do is I can simply write gmail.com in capital letters and bypass it. Right. Third example, third feature is order payments. So the most popular vulnerability that we find on order payment is price tempering vulnerabilities. We can do price tempering by manipulating values of the parameter, like price parameter. It can be a price parameter. It can be it can be fee, it can be rate parameter, it can be text parameter, it can be shipping parameter. So it's always not necessary that you have to manipulate the price parameter only. Sometimes the price parameter is properly validating, but the shipping cost is not getting properly validated. So yeah, you don't have to restrict yourself from by from from the other parameters. So it's not just the price parameter that affects the overall costing. That's our main parameter, but there are also some other parameters as well. Okay, so even if you are able to bypass, temper the shipping cost parameter, if it's a separate parameter, if you are able to temper it and you are able to bypass the shipping cost, then also it's a vulnerability. Manipulate values of price identifier for different items. For example, there are some applications they don't, when are able to, if you try to purchase an item, so it does not, when you intercept the request on a payment page, so it does not reflect a price parameter over there. For example, if there is an item of 100 rupees and I'm expecting to intercept the request and and expect a parameter price equal to 100. So it might not be the case. It might not be the case in all the scenarios. There might be some application they are giving identifiers to price. For example, 100, for 100 the identifier can be 3819, or for let's say $1,000, $1,000 the identifier can be 381169, anything like that, right? So you have to also manipulate these identifiers. You have to see if the price is coming as it is, or it is being controlled by a numerical identifier, right? Or any identifier. Okay, so that is something that you have to see. I'll show you example of both these scenarios. So this is the simple price tempering, where the actual price of the item was 11800. I manipulated it to 1, and I was successfully able to pay for it at 1 rupees, right? So always check that the tempered price is flowing to the payment merchant, right? For example, if you are manipulating the price, but in the end it is getting validated and you are not able to complete the transaction, right? Then it's not a vulnerability, right? Validation can be anywhere. This is the second scenario. See here, if you can see, I'm due to some restrictions. I mean, like I won't be able to disclose. I don't want to disclose the target names and anything that can lead you to know the target. So here, I I I, I hide the name of the targets here. So for this example, we will call this item S and this item C. So item S, by purchasing item S, you can take a car ride. By purchasing item C, you can take a boat ride. So the car ride is for $30. The boat ride is for $800. What I did, I intercepted the request, both the request, and I observed the price parameter. There was no price parameter. There were some identifier for the price parameter. For the this item S, the price parameter identifier was 381169, and for the item C, it was 381160. So what I did, I triggered the purchase for this item, sorry, and when I intercepted the request, I saw 381160. I replaced it with the identifier of this 381169. And I forwarded the request, and you can see I can buy the item C with the price of item S, like this. I even confirmed the order from a cash on delivery method because it was enabled over, and then later on I cancelled it. So this is how you can do price tempering. Uh, I showed you two different examples. Now the next one, public versus private profile and API UI elements. So there are some applications they allow you to set your privacy. For example, if I create an account somewhere, it would allow me to add details like my Instagram ID, my Facebook ID, the URL of my Facebook account, the URL of my YouTube channel, right? And also it gives you a feature to keep those details private. If you turn on that feature, this detail won't be displayed to the other users, right? But sometimes there is a miscommunication between the APIs and the UIs. So even when the privacy is set to private, it is enabled. If the privacy is turned on for that particular user account, there are sometimes UI elements, they leak those informations anyway, right? So this can be a scenario where you have to create two profiles, where you have to create a profile, set some values in in those public entities like Instagram URL, Facebook ID, etc. Then uh, make it public. After that, just uh, make your profile private, okay, and see on the through the UI if you are able to see the Facebook URL or Instagram URL or not. Now you are not able to see. If you are not able to see, check for the UI, view the source of the page and see if the URLs are leaking over there or not. So that is one test case that you can do. Social media account takeover via broken link hijacking. So sometimes applications provide thumbnails of the social media accounts or social media pages. So if those social media pages are deactivated or not active, sorry, not deactivated but non-existing, then you can claim those username in order to claim the accounts. I'll show you the POC for that. Allowing unintended data values to be sent in HTTP requests. For example, uh, there are some parameters that are not supposed to be sent through requests. But if the application is allowing sending them anyway, then it can cause to business logic error. We will see the example of it. So the first one, public versus private profile. Okay, here you can see this hacker boy app. I made an account hacker boy and I set it to the set it private. I turned on the privacy on it so that no one can able to see my can be able to see my URLs, Instagram URL, Facebook URL, etc. Right. But when I view source of this page and I search for the URLs that are injected in my YouTube channel link or my Facebook link and my Insta link, I can see all the links over here. You can see here vishal.com. This is something that I added in Insta. This is what I added in my YouTube. This is what I added in my GitHub URL. Even though these details are not visible through the UI, I'm able to see that from the view source front end code, right? Just note that I'm doing the for doing this test case, you have to see a profile. You create a profile, set it to private, and then open the link of that profile in a different browser from a different user session. So from an attacking point of view, this particular user is a different user, right? You don't have to see in the same window, right? So through this vulnerability, an attacker can see the private detail of the hidden details of a user who already set the uh, account privacy to private. Social media account takeover via broken link hijacking. So you can see this kind of thumbnails in the footer, right? You can click on these links and you get to see the social media pages of that particular website. So sometimes the URL is broken. If you click on the Facebook link or LinkedIn link or Insta link or Twitter link, it takes you to the Instagram page, but sometimes the page is not um, existing, right? So it might have been deleted, it might have been the name over there might have been changed, right? But that sometimes the developer forget to sync the names here and here, right? So for example, if I create my this is if, for example, this is my website and I added the values over here, like my Facebook page name is Vishal Private Limited. I injected the link over here in my website on in this element. I created Facebook page Vishal Private Limited, right? But I mistakenly deleted the page or I mistakenly changed the name of the page over here, but I didn't sync it over here. Right. So anyone who visits this link still goes to Vishal Private Limited, facebook.com/ Vishal Private Limited. Right. And this page is not existing anymore. So what I can do as an attacker is I can create a page called vishalprivatelimited.com. Okay. And anyone who clicks this link goes to the hacked page, right? The page, the social media page, which is controlled by the attacker, right? So anyone who visit the website and try to browse the social media accounts gets redirected to my Facebook page instead, right? So here, by this vulnerability, you can even abuse. You can do a lot of abuse by just posting fake news, or posting fake links, or doing social engineering with the users of that website. So there are so many things that you can do, right? So there is a tool called dead link checker. You can Google it. You can just enter any URL and it will show you the list of, it will scan the front end code of that particular website, and will show you the dead links, right? So you can use this kind of tools to find dead links and hijack them. Okay, third one, public versus private profiles and API UI elements. So this is the third POC for this particular category. Allowing unintended data values in HTTP requests. For example, there is a comment box where you can put comment on some video, and I put an abusive comment, or let's say I put a nice comment on a video. Right? Let's say I put a nice comment on a video, uh, but the person who uploaded the video, right, wants to uh, report my comment, and if you click on the report button, right, so this kind of request will be triggered. It will be containing the name, the username, my username, reason, offensive, okay, author, my username, and it is also, here you can see it is also containing the text. So this is not the thing that is controlled by me. This was something that was, this is a comment that was inserted by the user on my video. So having this in the request doesn't make any sense. But if I manipulate something like this, something here, like if I enter something really offensive, right, and I send it, then the moderator who is looking after all this report abuse requests, he will be getting this data. Then it is possible that he might be getting my injected data instead of the real comment, right? And he might take action on the user, even though, if for example, if I intercept this request and instead of nice I put something very abusive, okay, and I forward this request, then the moderator might get the abusive comment instead of the real comment, and he might take action on the user, even though there is no fault of that particular user. He didn't do anything wrong. He just put a good comment, but I manipulate it and I put an abusive comment over there. And this vulnerability arises because there was no need of having this text parameter in this request, because this was not intended. So the if the text parameter could not have been here, there should be any comment ID or something like that that can be here, right? Through which the moderator can just search for that comment ID in order to find the actual comment, right? But here the text is there, so which through which an attacker can manipulate data over here, send it to the moderator, and the moderator will take action on the user. So I'm gonna share some tips for finding business logic error vulnerabilities. Hunt on the application that you use in your daily life and you are very much familiar with the features. Like it can be Facebook, it can be Tinder, it can be Bumble, it can be Truecaller, it can be anything, right? Before testing a new application for business logic error, try to be a regular user for that application in order to see what is what is intended, what is not. For example, if you are using an application for a very long time, right? But you didn't use the premium feature for it, for that application, for example Tinder, right? So there are so many things that might come across your head. For example, you get a match, uh, for that you have some daily limit, right? You cannot directly text someone without matching. So this can be a test case in your mind that, yeah, from a free user account I was not able to you know text a person without matching that person. So this a kind of crazy idea might come into your head. Think of whatever you were not able to do due to free free user account, right? And try to turn them into your test cases, right? For example, on Truecaller, uh, without using a premium account, you cannot see the details, you cannot do unlimited searches like that, right? So try to turn them into your test cases. Try to make a list of things that you cannot do using a free user account, and try to bypass those limits in order to find new business logic errors, vulnerabilities, by abusing premium feature functionalities. Do not restrict yourself to common business logic error vulnerability. There are some examples that I gave you in this lecture, in this session, but do not restrict yourself to those examples only. There can be something new in your mind. There can be something. Um, there can be some vulnerability that you might find which is not explained over here, right? So do not restrict your imagination. You might find something which is new to everyone, right? So business logic error vulnerabilities have no boundaries. Right. Try to purchase plans for the target you are hunting on. So if you feel like you can afford a premium feature, uh, you should buy it, because if you are able, if you can buy a premium feature, you will be able to compare the premium and the free user account. This will help you to find more vulnerabilities. If you can afford it, you should really you should look. You can think of buying the premium plan, or if they are cheap. Okay. So thank you so much. I hope you really enjoyed this session. Uh, have a great day. Bye.